Good morning, good afternoon from wherever you are, and welcome to our newest Lucas-Nuelle webinar. Today we are going to present to you our topic, Servo Machine Test Bench. My name is Delaram and I'm here with my colleague and friend Marcela. She is from the product management of electrical power engineering and electrical machines and power electronics. So Marcela, we are going to show a video about our Servo Machine Test Bench, and in the video we will show a lot of different features about the system. But what I want to ask you before we go to the video is that what is exactly the Servo Machine Test Bench and what is new about it?
Good morning, Dela. Good morning, everyone. Our test bench for electrical machines is a complete system which you can use to investigate the behavior of electrical machines. And also, you will be able, by using our software, which accompanies the device, you can also emulate different type of loads. But like you say, this is well explained in our video, so I will invite you to watch it now. During the video, you can ask some questions using the chat function, and we will be happy to answer those questions after the video.
Exactly. So there is a Q&A tab and there is a chat tab. In the chat, we are always happy to see where you're from, every comment that you have. And in the Q&A tab, please type in your questions. Also in the middle of the video, we will be getting them and we will get back to you after the video. Enjoy.
I'm in front here of the Lucas-Nuelle Servo Machine Test System, and I would like to speak about drive technology. Drive technology is one of the most interesting, but also very challenging topic in training young people. At first, I'd like to introduce the Servo Machine Test System. The system consists of the control unit, this is this panel here, and then the brake itself, the black unit here. On the other hand side, we have our machine under test, that orange unit. This orange asynchronous motor is connected to the grid via a star-delta switch. At the first step, I like to combine the motor and the brake system. So you need no tools, it's very easy to combine both systems. Then I fix it with the screw, and then we have here a shaft cover which fits exactly between motor and test system. You can see here the green light. This green light indicates that no fault is occurring at the moment. So the system itself is very safe. There are no space between the both machines. The shaft cover avoid touching the shaft. Then each motor has also a built-in temperature contact. So if the motor is too hot or become too hot, it will trip and the control unit will stop. So everything is done for the safety with the Servo Machine Test System. In the latest version, we have also included, we call it EDD, electronic drive data. So that means every motor transmits his values via a special protocol to our unit here. That means the Servo Machine Test System knows which kind of motor is adjusted and do all the preparings for you. So it makes it much more easier than before to do all the settings. In the next step, I will show you the ILA course, which is coming with the system. The ILA course is in this way, that we start here for the asynchronous motor. On the first page, we see the training contents, the prerequisites, and so you see what is done in the course. Then you get information about the equipment. So at the first step, we have here the complete equipment list. And then for all relevant material, we have detailed description of all the things. Also, the software active servo is explained in every course. So, for example, if I go to motor characteristics, we will find also small videos which shows you how to operate the system. So here we see how it works, and so you get completely guided in front of doing the experiments. What I like to show you now is to perform 1 or 2 experiments with the system. So I will move to the experiments, taking the characteristic of a star delta switch. So I will move to the experiment page. Here we start again with the training contents for this special experiment. We see here in the next step the circuit diagram. So all the complete wiring, everything is done in a circuit diagram to be on the normal technical level. And in the second step, we have also a detailed picture which shows you step by step doing the assembling. For example, here the PC system, the PE connection, temperature connection, motor circuit, all the wirings are shown in this small animation. In the next step, you will get guided step by step during the experiments. That means here we see start the software active servo, select motor characters, and so step by step you get guided. So, and I will do this. So in the first step I will open the software active servo. So if the software is open, the PC is connected via the USB cable to the control unit. The complete supervising is done by the PC. In the first step, I like to record characteristic of star and delta circuit. So I will start the power supply and I will switch on the motor to the star circuit with the star delta switch. To start the characteristic, I will press enable here, then I have to switch the enable, the 1 button here on the control unit. This is a safety feature, so the software asks to push the button here, so the students or the student know that now something happens to our machine. Say OK. Then I press the output ramp button, and now the motor gets braked step by step from the no load speed to the standstill speed. And what we see here in the characteristic in the graph, that is the characteristic for the Y circuit, for the star circuit. The next step is, I will press the enable button again, and now we switch the motor to delta connection, and then we will see how the motor behaves in delta connection. I will press the enable button again, start the system pressing the 1 button, going to output ramp, and then the system records the characteristic for the delta. So I will switch off the motor, the software also, and what we see here is we have a big difference between the both torque. And so we see, okay, if the motor runs in Y connection, star connection, the torque would not be as high as in the delta connection. What should we do with such characteristic? For example, I like to see also what is other values given from the motor. So I make a double click here. For example, I select current, and I see, okay, that's the motor current. Then I can take this picture, say copy, and paste it to a special placeholder in our ILA course. These ILA courses are able to print out later if you have done the laboratory, and so you get all the information to take it back to home. Now we have seen one side of the medal. We have looked on the motor side, but motors in the industry are not only motors, they are applied to drive a working machine. And now we come to the working machine. For example, we have in the industry a big ventilator, and the idea is now to bring this ventilator in the laboratory. So what we did in the software or in the system, we implement the characteristic of the ventilator in our servo machine test system. So the black unit behaves now like this ventilator. So I move here, I move here to the point load simulation, and then I can arrange different load or working machines. For example, pump, ventilator, car lander, hoist drive, compressors, winding machines, inertia wheel, or time-dependent load. So we have all the well-known loads in the software, and they can used in the laboratory. Now I have adjusted the ventilator. The size of the ventilator can be changed by the value load constant. So I put a special value inside. Normally these values are given in the ILA course, so the student has to know which is the correct value. And if I press the enable and start the system, the black unit here, our servo machine test system, will behave like the ventilator. If I start now the motor, we see the working point comes across both characteristics between ventilator and the torque line of the motor. If I move to delta, I see the behavior. Normally, this behavior is shown on the whiteboard, drawing all the lines, and you see you have to believe that the working point is exactly at that point. But with the hardware here we have now, you can do it in an experimental way, which helps the student to understand the interaction between the both systems. Now the question is why we use star-delta connection. Star-delta connection is used to reduce the inrush current of motors. Let's try to do one other example. I will move to another working machine like a hoist drive, which could be a normal tooling machine in the industry. And if I look on the motor weight blade, I see, okay, this motor has a value for approx 0.37 kilowatt. And so the torque should be around 2 and something Newton meters. So I applied here a value of 2.2 Newton meter for the torque. And now I try to run the motor with the star-delta switch. I enable the load, press OK here, start to Y circuit or star circuit, and nothing happens. The motor couldn't start. There's no torque, not enough torque to start. We see here the working point is at this point and no turning of the motor. If I go to delta, I see, okay, the motor is turning. So for example, for this special machine, star delta is not working. But what is happening with the current inside the system? To discover the inrush current, I will choose another load machine, working machine. I choose the inertia wheel, and then I change the flywheel to 1000 kilogram square centimeters. And now I can also adjust the axis for this. I will choose 20 seconds. For the trigger, I can choose the speed, for example. And here with this small anchors, I can select the triggering point. So now I have adjusted the flywheel with the values. But for the inrush current, it's also interesting to see the current. With a double click, I can adjust the current here. Start enable again. and press record button. What we see here is now all the values are measured, and now I can start in the next step the motor. If I start the motor in the Y, see what happens, and then I switch to delta, and I can see directly the behavior. So we start here with a small current, then with a higher current if I switch to the delta. And we see also the torque which is given by the speed up of the system. If I stop it again, press stop. The challenge now is to reduce this inrush current up to, I will say, 1.5 amperes. So the students has to find the right time, the correct value to do the switching, to understand what happens. So this knowledge can be used, transfer later for the industry to understand what happens then. So what will we do? We will do the same experiment again, press 1 again, press record again. And now I start in Y circuit, and now I have to wait until the right point is given to switch to delta connection. And now we see we have reduced this high inrush current to a small value. I will stop it here. This demonstrates you how easy it is to bring these things to the laboratory to understand what happens. So we have real life situations in the laboratory, and we have the tools to show it, to visualize all these things and make it clear. That's for the students and the workers for tomorrow. They understand the behavior between motors, drives, and working machines, and can transfer this knowledge to the industry later. The experiment I showed you was only a first impression of the system. So we start with an asynchronous motor, but the system can only also handle DC motors, synchronous motors, AC motors. Every kind of motor can be used with the system. Or you can expand the system to a real power electronic system like frequency converter, industrial or didactical ones. So you can use it in many ways. If you have further questions, please visit our website or contact us.
So good to have you back. Thank you to Rolf and to Marcela and all the product management who prepared us with this great video. So we've got some questions in the meanwhile. If you agree, I'll just read some of them to you, and we will get back to the conversation.
Yeah, sure.
Okay. So the first one, there is a question about compared with the old model, what is the new characteristics about this? What are the differences here?
Okay, this system is improved in safety features. Mm-hmm. For example, the cover between the servo machine and the test machine doesn't have any gap anymore. In the past, it was not completely covered. Right now it is, so it's more student-proof, like I will say.
Okay.
Additionally, we have this electronic drive data, which means that the system recognizes automatically which type of machine is connected to the system.
Is that why we have different colors on the shaft cover?
No, the reason why we have different colors, like green means everything's good. The system is now prepared to be operated safely, mm-hmm. and everything is fine. Once the LEDs start blinking means something is not correct, and you must review what's going on in the system. For example, like we had in the past, the temperature, it's continuously being measured on the motor, and once the motor gets too hot, then it will send some signal to the system that, okay, stop, I cannot work anymore. So you have to wait until the motor cools down, for example.
But these temperature connections were already there in the system before, so the student had to connect it up. Is something new about these temperature connections, or?
No, not really. They were as well as for the old system, as for the new system. The only difference is that right now, for example, we have this touch display on the control unit, which allows you to observe, apart from electrical and mechanical values, important mechanical values, and also select the different types of operations. You can also directly observe whenever the system has an error. In the past, we have to look back on our quick chart. I don't know if you remember. Right now, with this new system, you can directly see on the screen which type of error the system is having, and then you can continue with the troubleshooting and correcting this error in order to perform the experiments.
Okay, that's amazing.
Additionally, we have an integrated power protection switch, which disconnects the system from the grid once one error is detected, and it makes the system
really safe.
Correct.
That's really good, because the students are always careless. They might do something that might damage the system or hurt themselves. So if we've added this many safety features, I think it's a really great improvement.
Correct.
What other software? So beside the hardware, it's our ideology as Lucas-Nuelle. We not only offer the hardware, we also want a blended learning, which includes the software, every different material that a student needs in order to learn better. What are those softwares that are with this system?
Correct. So let's start with our intelligent learning platform, which is called LabSoft. This platform is where we display or we show all our courses, not only in electrical machines, but also in power engineering, smart grid, automation, all of our product areas. Specifically for the electrical machines topics, we have many experiments which will help students to understand the basics of electrical engineering. Together with the labs, of course, we have over 150 virtual instruments which will help us also to perform some measurements on the system. And one important software which comes always with the Servo Machine Test system is the active Servo software, which we have also improved in many different ways. For example, now we have made it user-friendlier.
Okay.
That means with this electronic drive data, the system recognizes automatically which machine is connected, and you don't have to adjust the settings anymore. It will be done automatically. Additionally, the selection of the different type of load machines, which we could observe on the video, it's done way much easier than on the past version. Good news for you, this software is also compatible with the old system. And I hope I have answered your question.
Yeah, so you shortly mentioned, also Ralph mentioned it in his video, that different type of motors can be connected up to the system. It doesn't matter which type of motor it is, it will automatically get detected by the system.
That's correct. You can connect to the system a synchronous machine, DC machine, servo motors, reluctance motors, any type of well-known motors which we use on the industry. We can connect to our Servo Machine Test system, and we can perform many experiments in order to investigate their behavior.
Their behaviors. Okay, and what power levels does the system offer?
We offer this system in 300 watt and also in 1 kilowatt.
Okay, so for like these are also the research used as in for research purposes for students who are basically maybe learning something new or researching on some different type of motors. For us, who would be the end user of this system?
This system can be used in all levels of education, starting from colleges, technical schools, until high and top research institutes, because the system is able to be connected, for example, with our SCADA designer software. The device is included there, and there you have the possibility, the chance to program some, for example, additional loads, which you can also emulate on the system.
Great. You also mentioned shortly about other type of systems that we have. So you mentioned about the bigger systems like smart grid, about microgrid system, about other systems in power electronics. So this test bench can be integrated in those systems, or is it being integrated in there?
That's correct, Dela. Apart from just investigating the behavior of electrical machines, this system is also used on power electronics combined with our converters. There we have the chance to combine these two systems and perform some modeling using MATLAB and Simulink. We have different courses for that purposes. We also use this servo machine test system in our power engineering lab, as in we simulate the behavior, for example, of wind power plants, or for example, hydro generation and many other types of power plants.
So it can also be used as a generation, not only as a load, as also a generation.
It's correct. This system works in the 4 quadrants. And it works as a motor and also as generator.
Can you name us some examples in which courses or in which products we are using the system as a generation?
Like I told you before, we can use it to simulate the behavior of a double-fed induction generator, like in the wind power plant, or in our power stations course. You can use it to emulate the behavior of many types of different power plants, like, for example, hydro power plants, or nuclear biogas, combine steam and I forgot it. Steam and gas power plants, and many other different.
Okay, it's a great thing that the system is modular. You can just basically fit it into any sort of system that you've had before, or just basically create your own systems. If that's can be actually a really interesting topic for a student who is writing their thesis on some topic, they can do a lot of things with our systems. In this meanwhile, we got a couple of more questions. Yeah.
Yes.
There is a question from Asha. He's asking which type of temperature sensors are used in this motor.
Oh, well, for this, we use common thermistors, which are located on the motor. And once the motor gets too hot, then the sensor will send a signal to the control unit, which will of course disconnect directly the system, and until the system cools down, and or maybe the connections are not well done, then the system won't work again until the error is
resolved.
Correct.
Okay. Nahida is asking about the software. If the software works as a simulator, or do we need the motor to get the results?
I guess you are talking about our active servo software, and for this you will need the motor in order to perform the experiment.
But in active servo, I've seen that you can just basically with one click change the type of motor or change the type of load that you want to simulate. Is that so?
That's correct, but if you want to simulate the behavior of the motor as a different load, you will still need a machine, a test machine.
Okay.
Connected to the system.
Okay,
yes.
Can you name maybe a couple of the loads that we are offering in our?
Yes, sure. Like you could observe on the video, the system can emulate a pump, a fan, a calendar, crane, compressor, winding machine, inertia wheel, and even a time dependent load, which you can easily create like your own torque profile, and the machine will behave as this model that you have just created.
Yeah. Great. The next question from Frederick, for other experiments like in EUG2, does it use the new servo or still use the old model?
For people who doesn't know what EUG2 means, that's the synchronization system. Yes, this new Servo Machine Test system will be integrated also in all of the smart grid systems. Yes, it will be there.
Okay, so I'm not sure if that's a question, but I will read it for you. From Nenad, is there any, oh yeah, there is a question. Is there any possibility of getting mechanical characteristics of the induction motor obtained in Lucas-Nuelle experimental bench in any data format, like in CVS or Excel or similar, suitable for numerical analysis?
Yes, sure. All the data that you capture or measure with the active servo software can be exported as a Excel table, correct? So you can process this data in different data processing tools like MATLAB or Simulink, for example, and you can even create your own models.
Okay, so this person has developed a 3-point method based on a class formula for obtaining braking slip and braking torque. I think it's something for the research purpose.
Yeah, correct.
And would like to test it on such characteristics.
Yes, sure. Like we mentioned before, the system can be used together with MATLAB Simulink or any other similar data processing tools. And yeah, so I really hope you can
have fun with the system.
Yeah.
Okay, now I think there is one more question. Asha is asking which type of signal is used to communicate for the communication of the drive. I'm not so sure about the question. Maybe Asha, if you could explain a little bit more, what do you mean? Then we will get back to your question. Otherwise, is there something you would like to add to the conversation? Maybe about, I don't know, how you have found it. I'm pretty sure that when you started, you also found our systems very interesting for a student to learn, even when they don't know much about about everything at first. But when they start from the basic, they can just like have their own pace, start learning, and at some point get to the level where they feel more comfortable. It's very interactive.
Yes, it is. And actually, if I compare the system with how I used to learn on the past when I was studying, like I had to take all the measurements by hand. And with this system, you can actually take many measurements, not only one, but many at the same time in seconds, which makes this really much easier for students to understand and to investigate all the features on all the characteristics of the motor.
Every data basically that is going on in an electrical motor.
Yeah, sure. And actually, our courses are designed on a way that students can work step by step. They will find some understanding questions that they can directly answer, and the professor or lab assistant can supervise the like how they are doing with the system, if they are understanding, and
but not only that, we also have like a lot of experiments that are very close to reality.
That's
like the
true.
real life experiments that are in the courses, and the students can just basically work on their own pace. If someone learns slower or faster, that is all up to them. It's a great way of teaching. It's, I think, the future of teaching. It's how every student should be learning at this point.
Yes, it is.
Yeah. Great. So we got, in the meanwhile, one more question about the type of software. Okay, I think we've already answered this. And I cannot find any more questions. I think we've answered everything. You've done a great job. And also Ralph has done a great job explaining in the video. The video was very complete and self-explanatory. And I think there is one more thing that I'd like to mention, is that all of these webinars and the videos that we have provided will be available for you for later on. You can find them on our website and on our YouTube channels. You can get back to them, watch them as many times as you want, or share it with your friends or colleagues. And in case of any questions, you can always get back to us. You can get back to us through our emails that you have probably seen on the registration website, and we will try to help you as much as we can. I think all in all, do you have something to add?
Yes, I would like to mention once again that the software Active Servo is compatible also with all systems. So if you want if you want to update your own Active Servo, which you might just already have, please visit our website on product area under downloads. Then you can find the latest version of the system. Like we said before, is user-friendlier, and it will be a big improve even if you want to still use the old system. All motors are also compatible with the new system. And yeah, I think that's it.
I think we've explained everything. And anyways, if there are any more questions, I think we can stay in the chat for the next 10 minutes. We will get back to your questions. If you got still one more question, just type it in. Feel comfortable. And otherwise, you can always get back to us through our emailing. And thank you for your attention. And we really hope to see you in the future.